Now, why can't we see inside our bodies already? You may think the answer is really very obvious, because we see with visible light, and visible light just bounces off stuff. So, since the light doesn't get inside us, we haven't got any chance of seeing inside us. That sounds perfectly reasonable, but it's actually not true. Let me see if I can show you that it isn't true. If we could have the lights down. I've got my bicycle light with me, ordinary red light, and if I try and cover it over with my hand, I think you'll agree that actually you can still see the light. It easily goes all the way through my hand. And that's a pretty neat trick that we can immediately put to quite some use. And before the lecture began, I asked James here to put a little gizmo on his finger. So James, if you'd like to come and show us what it is that you're wearing. This little gizmo is telling us some stuff about what's going on inside James's body. It's telling us that his heart rate here is 84, and we can see a trace of his heart beating at the bottom. And it's also telling us how much oxygen there is in his blood. It's telling us that he's at 98% of the maximum amount his blood will hold. And he's a pretty cool customer because he's managing to keep his heart rate down at 86, whereas most people, as soon as they see it, starts to rush up. Thanks very much, James. You can take a seat now and take the gizmo off your finger. What's going on inside James's finger? Well, let's take a look. Basically, he's having some light blasted through. In fact, there are two different colours of light. One is red and one is infrared, so red that you actually can't see it. And both are absorbed by different amounts by oxygen in the blood. As the heart beats, so the oxygen in the arteries cause the amount of light that comes through his finger also to fluctuate. So we can immediately find out what his heart rate is. But the amount of light that's absorbed is different for both the red and the infrared. So by looking at the ratio of the different amounts of light, we can also figure out how much oxygen there is in his blood. Well, that's a neat trick, but it isn't actually imaging. We've got no picture of James's bones in his hand or muscles or anything like that. So why can't we use light to see inside the body when it does actually get inside the body? Well, let me see if I can explain how that is by showing you a little demo over here. What we've got here is a light, a lens, and a screen. And we've got an image of that light on our screen. And I've got some water here, which has just got a little bit of milk in it. So it's a little bit cloudy. It's like the stuff that our bodies is made of. So if I bung this in the light path, I hope you can see that there's still a fair bit of light getting to the screen, but suddenly we haven't got a picture anymore. And this is something that should be fairly familiar to all of you that have looked out on a foggy day. If you look out at this bridge, you can't see the far side of the bridge. Why not? Well, it's not because there's no light coming from it. This picture is very bright. There's loads of light coming from the far side of the bridge, but you can't see a picture of what's there because you only see the last thing that light bounces off. And in this case, it's the particles of water in the air. And when we bung some light inside our bodies, all that we see is the last thing that the light bounces off, and that's right at the surface. So we only end up seeing our skin. So what we need to see inside our bodies is something that will get inside but not bounce around and interact so much.